Sweet. So I'm super excited about this. The opportunity to talk to students about the Julia language is something that I really enjoy, and I think again there we'll talk later on about sort of why I feel this way. But really, I just think it's such a great learning opportunity for students, and I have personally in my career journey, as you were mentioning before, learning Julia and sort of having this experience has benefited me immensely. And I know this presentation says March 20th, 2020. That is sort of how it feels. This is an updated presentation for today. I just forgot that it was 2021. So I'm going to dive through and really just talk about the Julia language, the programming language at a high level, and some of the community aspects of it. We might even look at some actual code. What I would encourage folks to do is, if you haven't heard of Julia before, which there's a good chance that you haven't, I would go to julialang.org, which you can see the URL in the corner. Download it. Feel free to multitask during this presentation. Play around with the code. Look through a Hello World example if that's of interest to you, and that way you're sort of engaged as we go through this process. So if we think about, this is always such a great question that I like to think about whenever someone comes peddling something new, like a new programming language. I think it's important to sort of take a step back and ask, what is the need for this new programming language? Why do we want to learn something new? We all probably here know Python. Some of us might know R, MATLAB. We've all had to go through the process of learning C++ and Java. So what is the advantage to having another programming language on top of all those ones that we all already know? And I think if we talk about sort of the way that science in a lot of cases has been done in the last 25 years, you have this sort of two language problem. And the way that this materializes itself is you have folks who are more so focused on the actual science of solving a problem, whether that be medicine, biology, astronomy, whatever the specific scientific field is. All of those folks, for the most part, are doing their development in a high level language. If it's Python, if it's MATLAB, whatever it is, they're using that high level language to do all of their initial development. And then when they come to a solution, when they figure something out, they then have to take their code and then translate it into C++, Java, C, in order to deploy that into a real world application. And this, you can sort of already start to see what the problem is. You now have to pay scientists, and then you have to pay software engineers to actually translate that. And there could be a bunch of disconnects in that process, tons of question marks around how successfully that process could be done, and then you go and deploy your application. So that was sort of the traditional way that something like this was done. So the folks who created Julia were sort of thinking, how can we compress the innovation cycle with Julia? And the way that they were able to do that is by making a high level language that is as fast as C and C++, but has syntax that's actually a high level language like Python. So if you know Python, you would be comfortable with the syntax in Julia, which is really cool. And again, it just makes it so that it's a more productive environment for developers. And if we talk about sort of the community and the package ecosystem and where Julia is, in the race of programming languages, it's going really well, I think. So far, as of January of 2021, 25 million downloads of Julia, growing like 100% year over year, which is awesome to see. 10,000 plus daily downloads, 5,000 registered packages. It's being taught at a bunch of universities, being used by a bunch of companies. And it's actually, again, one of the fastest growing programming languages, along with Rust. If you've heard of Rust before, I think Julia and Rust are usually sort of in competition with each other, proverbially, to see which is sort of the fastest growing of the two languages. So it's always nice to have a little bit of competition, but lots of good things happening, lots of growth recently, and it's you can sort of attribute a lot of this back to the Julia community and all of the good things that the people are doing. I think it's, again, sort of taking a step back and looking at the community, if you're familiar with programming in other languages, there really isn't a core community around some of these other languages. And perhaps this is just my experience, but when I learned Python, when I learned C++, when I learned Java, if I had a question about how to do that, if it was outside like the specific domain of my, whatever the class it was that I was learning that language in, if I went and posted that question on Stack Overflow or something like that, the experience and the community was not great. Like, it's about learning those languages for me. And I think in the context of Julia, you have this really supportive and helpful community that's truly interested in helping you learn the language. And I think in the case of C++ and some of these other, Julia is being used. I started using Julia when I was working at NASA back in 2018. We were using Julia to do some simulation and modeling for lunar rovers, which was really cool. I'm no longer a part of that team actually, so but it was a great ride, and using Julia was the perfect tool for what we were doing. So it was a lot of fun, but lots of other places using Julia. So if there's these companies are of interest to you, then learning Julia might be a good tool. Lots of universities teaching Julia. I think the important call out here is that if you're interested in learning Julia from folks at MIT, there's actually an ongoing class right now. It's Introduction to Computational Thinking using Julia at MIT. If you go to computationalthinking.mit.edu, it's an open free course for anybody. It's not I don't know if it'd be considered a MOOC because it's like taking place live right now. But again, if that's of interest to you, there's a Discord, and students and professors are sort of interacting there, and it's a great experience. So a cool way to learn Julia if you enjoy sort of the traditional classroom environment. So this is sort of just showcasing Julia in the news. If you type in Julia on like Google News or something like that, there's a good chance you're going to see all these articles about Julia versus Python, Julia versus all these other languages. I think it's worth digressing for a moment and just talking about the reality that despite all of the articles' headlines, it really isn't a competition between all of these programming languages. I do think that the future is a positive sum game with respect to these programming languages, and I think Julia is going to do really well in the future. I think Python is going to continue to do really well in the future. So many people know it. They have the network effects of what's happening with their language. So I don't think that it's a winner take all with respect to the future of these programming languages. I think if you know Python right now, it's going to continue to be a relevant tool. If you've learned Julia, it's going to continue to be a relevant tool. So, but a lot of the articles that you will read about Julia versus Python and all this other stuff might say otherwise. So I think it's always worth pointing out to folks who are first learning the language. If we talk about sort of, again, some of the reasons why we sort of talked at a really high level briefly earlier about why folks would want to learn Julia. But if we go back to sort of some of the really specific reasons why people would want to learn Julia, again, we had mentioned the speed, the ease of use, the high level syntax similar to Python, the productivity you get from being able to just write your code once and have it work and have it be fast right out of the hood. It's also scalable, supports GPUs, works on all the major clouds. If that's of interest to you, that's more of a corporate thing, I think, of interest for students. But if you're working on some cool project and you want to be able to do it to deploy it, I think working on the cloud is something that's important. The other piece that's of interest, and this is always one of the challenges for me personally, is that, I don't consider myself to be like a big math person. I like math. I think it's really cool. I'm not very good at it. But Julia actually allows you to be as close to the math as possible. If you pull up Julia code, and I've seen this, there's a bunch of really great tweets that show this. That if folks are interested, reach out to me and I can send you a link to it. But it shows like the Julia code, and then right next to it, it shows like the mathematics that will show up in a academic paper. And if you look at the like lines, right, like line by line going down, it's really close. Like the syntax in Julia is close to what the pure math looks like. And this is something that's super exciting for academics, because again, they can take what they already know, which is how to do math and how to, do academic stuff, and then they can actually go and directly translate that into Julia without having to learn all this new syntax and have things be completely different. So that's a really interesting and exciting thing about programming in Julia. So if math is your thing, this could be a great opportunity. Some of the more interesting use cases, Celeste, which was one of these collaboratory projects between a bunch of different groups, but essentially they were able to model a bunch of things in the sky and use a ton of computational power to do this. Julia is one of few programming languages that's part of the petaflop club. I think C is one of the other languages, and perhaps C++ as well, but essentially just able to do a bunch of computational processes that a lot of languages just can't handle because of the design of the language, and Julia was one of those. So it's a cool, interesting language to use if you have sort of these grand ambitions for what you want to do computationally. And another really good example of that is the Klima Project. So the Klima Project is another one of those sort of grand, ambitious projects where they're actually looking to build climate models on the scale of the entire planet, which is crazy. And it's sort of, if you think about how complicated the world is and the environment is and the ecosystem, almost within like 5 seconds, I'm like, how are they ever going to build a climate model that is reflective of the entire world? But the reality is that it's a computational problem. It's not a problem of what's necessarily like physically possible. They can definitely do it. It's just a question of getting the platform and the code right. And I think it'll be really cool to see what ends up happening with the Klima Project in the next few years, because they're sort of well positioned to be one of the leaders in sort of helping to solve the climate change crisis. And again, one of the key aspects of solving climate change is understanding what's actually happening. It's the environment is complicated, and the more that we sort of know about the environment, the easier it is for us to ascertain, what we can do to actually help solve the problem. So this is a really cool project, and I had the chance in 2019 to go down to Caltech and meet some of these folks, and it was a super cool experience. And they were all really smart, and they're giving a talk, and all the stuff was just going way over my head because I know nothing about climate science, but it was a cool experience nonetheless. One of the other projects that I think is really interesting is the Pumas project. So Pumas is essentially it's focused on pharmaceutical modeling, and one of the aspects of this is personalizing medicine. And I think this might sound intriguing to folks, and the way that I like to explain it is, all of us on this call right now, all of our bodies are completely different. What we do during the day is completely different. What we eat during the day is completely different. We all exercise a different amount, and the result of that is our physiologic undertones of our body are all different. So, the basic idea is we're all completely different. But if we go into the doctor and we have the same symptoms and we go to the same doctor, the prescription that we get for a specific issue is going to be the same. They're going to say, take 2 pills of this antibiotics twice a day for 3 weeks. And it doesn't matter, all the specific things about my body, that's still the same diagnosis as you're going to get. And I think that's sort of one of the most interesting things to me that I've thought about recently, that very fact that they do that. And what the Pumas, sort of the personalized medicine branch of Pumas, set out to do is say, how can we actually make it so that the amount of a specific drug and the diagnosis for a doctor is actually specifically personalized to each person who comes through that door. And I think that's such an interesting application of computer science and pharmaceutical modeling. So if that's of interest to you, Pumas.ai is their website, and they're doing a bunch of cool stuff. And the other thing is they're actually helping with speeding up the development of vaccines. So I believe they helped Moderna with the COVID-19 vaccine, which is really, really cool. And they've also been working with Pfizer to increase the development of metabolic drugs for Pfizer by like 175x or something like that. It used to take them like a day or two to run a simulation, and now they're able to do it in like 30 minutes, which is crazy. And the sort of side note to this is that if you all aren't aware, the COVID-19 vaccine was actually developed by all of these pharmaceutical companies in like 2 days or something like that. As soon as they had the genome sequenced, it was sent over to these companies, and they figured out the vaccine that's going into people's arms right now, like within 2 days. And then all the other time that's been spent has been doing clinical trials to validate that was actually the correct vaccine. But again, it only took them 2 days. So theoretically, they could have just started popping in people's arms. That would have been bad because they didn't know what all the effects would have been. But that sort of underscores sort of the coolness of this computational problem and the fact that they were able to figure it out in only a couple of days. It's really a marvel of science. There's a bunch of other interesting use cases too of where Julia is being used. So if none of those intrigued you, one of the really cool, interesting ones that I'm slightly familiar with is the Safer Skies one on the left-hand side. So the FAA, which is the organization that regulates all of the air traffic in the United States for airplanes, they actually use this program called ACAS-X, which was written in Julia to basically make it so that airplanes don't crash into each other, which is really interesting, a cool use case for Julia. So there's definitely some world-class packages in the Julia ecosystem. I think some of the ones that make a lot of these use cases that we just talked about possible are the differential equations, the scientific machine learning packages, Flux, Jump. All of these are sort of world-class packages. There's definitely, the Julia ecosystem has regular packages that sort of just like compete against all of the, not compete, but just sort of fill the same need as a lot of the traditional Python packages. But then again, those are sort of the differential equations, Flux, SciML stuff is the best in class leaders as far as those ecosystems go, which is really interesting to see sort of Julia leading the way in those specific domains. So now to the sort of interesting stuff for students on this call. One of the cool things about the Julia language is that we get to be a part of Google Summer of Code. And we've been a part of this for many, many years now. And we actually just happen to be right in the middle of the exploration phase. So you're welcome to go to the Julia Lang website and check out some of the projects there. Last summer, we had 24 students through Google Summer of Code / what we call Julia's Season of Contributions. And then we also have a great opportunity to learn the language and sort of at a really at a really high level, again, the question is why learn Julia if you're a student? And I think one of the most important pieces is the fact that you get to bring new skills to a future job. And I think if you've ever worked in an internship, or had a full-time job, one of the first things that they people, if they're doing a good job at the company, are going to tell you is that they're not bringing you in to work at this company because you're the smartest computer scientist in the entire world. That the reality is there's lots and lots of people who have more experience doing computer science years ago. Um, And I think Julia is one of these things. I think, if you come in with this, fast programming language and nobody else knows it, and they're like, well, we have all these computational problems where we need to speed things up, this would be great to use Julia for these use cases. I really think that that's such a powerful way to sort of sell yourself as a candidate for different roles. Um, the other piece, and this is sort of something that is really exciting for me, is that there's so many, if you look at the Python ecosystem as an example, pretty much all of the quote unquote lower hanging fruit has been snatched by folks and sort of been solved already, whether that's, asking questions or building packages. A lot of that stuff already exists. And I think in the Julia ecosystem, there's opportunities to do things that don't require like 2 years of development time, but you can still make something that's impactful, and is used by the community for an extended period of time, which again I think is something that's really cool, and also a really great opportunity for you to say, like, in a job interview, like, yeah, hey, I built this, whatever type of package it might be, and yeah, now it's being used as like one of the fundamental packages in the ecosystem. And there's 100% people in the community who have done that, whether they were a student or what have you, and they've built that package and have been able to leverage that to do whatever it is that they wanted to do. And again, as we alluded to earlier, there's a real community with respect to Julia, and it's you get to meet people and work with real humans and sort of be a part of something greater than yourself, which I think is a lot of fun. And the last piece is there's always lots of great opportunities to talk at conferences. Folks don't know Julia for the most part, so whether you're sharing your experience um, at the annual Julia conference, or whether it's a presentation like this and you're just sort of sharing the good news, as I say, about Julia with folks, there's tons of opportunities. And the last piece is, who doesn't love programming and learning a new language? So I'm gonna pause here for a sec and see whether or not I wasn't able to see any of the chat. So I want to make sure I didn't miss any questions in here. Akash says, wow, that's really amazing. I agree. Indeed, really amazing.
There have been no questions till yet. But I think, like, initially, before attending the workshop, probably the amount of questions I had about Julia are now just falling in place with the slides.
Yeah, before I can show a really quick demo. I don't have anything super extensive to show as far as the demo goes, just some like really high level syntax stuff. So if anyone, any questions that folks can think of before we roll into that demo, I'd be happy to take those down.
Yeah, people, just put your questions in the question tab or the chat anywhere. Anyone, we'll just delegate it to Robert.
Cool. Well, then I'm going to hop into a really quick demo, and we can always take some questions as we're going through it. Awesome. You should be able to see my IDE now. We're using Atom at the moment, which is just a open source IDE created by GitHub, actually. Let's talk about some of the really cool things that sort of I enjoy most when I'm programming in Julia. And I think again, this is sort of coming from somebody who uses, I actually truthfully use Python probably the most for my development. And one of the challenges that I personally have with Python is sort of the managing all of the package dependencies and things like that. And if you sort of the question, and folks are being quiet right now, but the question that I would ask is, if you know how to manage your package dependencies correctly in Python, then we'd love to get you up on the stage and sort of give us a demo, because I've been using it for 5 years now, and I still have no idea how to correctly manage my packages in Python when I'm, when I'm adding a dependency. How can I make it so that somebody else, knows what packages to use and all that stuff? And I know there's the requirements.txt file and all that stuff, but it's not super clear how that process works and how I can check my dependencies, like all the different environment stuff. And I'm going to show you in this demo sort of how simple it is to sort of handle all these things. And again, this is important if you go through that process and you send someone else your code. And one of my close friends was just going through this with a Python project that she was involved with. Somebody sent her a Python project. It took her an entire week to figure out how to get the correct dependencies installed for that Python project. And with Julia, if we take a look at what we're looking at right here, so we're in the REPL, which is at the bottom. It's just a read, evaluate, print loop. This is the same thing that you would see if you typed in Python or Python 3 into your terminal, and then it would pop up the Python REPL. So, I can do all the normal stuff that you do in a REPL, like 1 + 1. It'll give me 2, all that good stuff. It's just a normal REPL. But one of the cool things is I can actually type in this character, the left-facing square bracket. And when I type that character by itself without the quotation marks, it actually takes me into the Julia package manager. So I'm able to do status. And right away, we can sort of see how cool and helpful this package manager is. So I type in status, and it's telling me here in this environment, in your .julia environments version 1.5, these are all the packages that you have installed, and these are the specific versions of those packages which you have installed at the moment. And this is something that, again, still, I don't know how I would do this in Python. It's just not a helpful and friendly process. And again, if we wanted to go in and like add some packages, for example, let's just take one of these random packages that we have in here, Slack, for example. So I already have Slack installed, the Slack package installed. I'm going to rm Slack, or actually more verbosely, I'm going to remove Slack, and this is going to remove the package from my environment. If I did status again, you would see it's no longer there, and then I can actually I'm going to add it back in. So this is getting added in from like a global registry. So if you're familiar with like the process to get a package into the pip registry for Python, similar sort of ideas for Julia, in that you would want to you have to go through some process to have it be a part of the official registry, and that's sort of what happened with this Slack package. So now it'll add it in, and it'll do all that stuff. And while it's doing that, let's look at some high level syntax. So at the top of the file, if you're familiar with sort of how you would import dependencies into a specific project, this is what the syntax would look like in the case of Julia. You'd say using and then the name of the package. In this example, I'm just going to say using Slack because that's the name of the package that we just added. The syntax to sort of print things should look identical to Python. Syntax for strings, going to look identical to Python. Looping through stuff using the for loops should look really familiar. The difference, and again, this is something that I enjoy about programming in Julia. The difference is there's no colons at the end of the line. So usually in Python, you would have to put a colon there. I always forget to put the colon, so this is really helpful for me. And the other thing is that this end keyword at the end of a code block is really helpful in that, when you get a more complicated Python file, it becomes really difficult for me, at least visually, to see like, where where is the end of one code block and the beginning of another, especially when you have like really deeply nested code. And one of the projects I'm working on right now has like super deeply nested code, and I continue to like near the bottom when there's like no code anymore. I'm like, I can't figure out where the indentation should be correct. And that's the really nice piece about this end keyword, is it gives you a visual indication at the end of the code where you should be lining things up. And this end keyword is the appropriate way to like end an if statement. So if you say if, some condition, you would still put an end at the end of an if block. You would put an end at the end of a function. Any sort of logical code block, if you will, is something that you would put an end keyword at the end of. So now I have this code right here. If I just want to run it and make sure that I'm not lying and that everything is working the way that it's supposed to, it's going to pre-compile Slack, all that good stuff. Someone's mentioning in the chat that nesting code in Python is very confusing in large code bases. Julia has an edge at this. And yeah, I definitely agree. I have like a 400 or 500 line Python file right now, and that's not even that big comparatively, honestly. And I have this exact same problem in that it's really difficult to tell sort of where visually things start and things end. If you give me 1 sec, I'm going to close my blinds because the sun is just coming up because it's 7:38 a.m. in California. Cool. So if we go back to this really quick, we can see I wasn't lying. Things happened as we would expect. We get hello world, and then in the for loop example, we're able to loop through and print all the individual characters that are part of this string. So this is sort of at a really high level what the syntax and structure would look like as far as programming in Julia. Are there any questions that folks have about this process, any of the syntax specific stuff, package stuff that we've talked about so far? If not, I think that's all I have, and y'all can have 20 minutes back this morning if there's no further questions. But yeah, that's everything. So I would again say at a super high level, if folks are interested in Julia, you can go to the Julia language website. There's a learning tab that sort of has all of the really cool stuff, different ways that you can learn Julia. I think that's sort of the place to start. If you've gone through some of those resources and you're like, okay, Julia is cool and there's interesting stuff happening that intrigue me, checking out the Google Summer of Code page that we have on the website, seeing if there's projects that your specific background would be well suited for, and then try to get involved as soon as possible. I think that's if you've watched any Google Summer of Code how-to videos before, that's the best thing that you can do is get involved as soon as possible, and connect with a mentor and express your interest, and then also hopefully make some sort of quality contribution before Google Summer of Code actually happens. And that way you can sort of show folks, hey, I'm interested and I'm serious about this, and I have these skills given this contribution that I've made already. So I think that's the same for the Julia language. If you can do all those things, you'd be in a really good position for one of the slots. So I wish you all the best of luck. And if there's anything that I can help out with as far as that learning process goes, feel free to connect with me, and I'm happy to point you in the right direction. But again, that's sort of all that I have. So if there's any last minute questions, happy to answer them. Otherwise, this has been great, and I'm super glad that I got to share the good news with you all.
This is awesome. Logan, I have a quick question. Like, seeing the syntax, it is being really close to MATLAB, like this syntax of Julia and how it is written. How different it is from MATLAB on the basis of like the computation ability and all. Like MATLAB tends to be a bit slower. Like the point that I have used MATLAB, I have seen like at places where I need to have huge amount of computation, MATLAB goes out slow. How does Julia do it better?
Yeah, that's a really good question. So there's sort of a few different pieces to unpack there. I think just sort of a really side note is that one of the co-creators of the Julia language, his name is Alan Edelman, and he's a professor at MIT, and he's also just one of the core founders of the language. He was actually the first. He had license #1 of MATLAB. He was the first commercial user of MATLAB in the entire world. So he's very intimately familiar with the language and sort of some of the pitfalls that come with it. As far as there's sort of two parts to the question. Why, does Julia have those same performance bottlenecks that MATLAB does? No, it doesn't. And the reason for that is because of the intentional design. Julia is it is JIT compiled, so it's just in time compiled. The folks in the Julia community actually say it's just ahead of time compiled, which is just sort of alludes to how good the compiler is. But again, you don't see these performance bottlenecks with Julia as you would in MATLAB, again, because of this intentional design. I do think that MATLAB has a leg up in their the visual GUI interface builder in MATLAB is actually really cool. I got to use that during one of my internships, and I was able to spin up a fully working, someone gave me a bunch of MATLAB scripts, and then I just put a user interface on it, and it took 2 hours or something, and that was really cool. But from a computational perspective, I think Julia has the leg up in that respect.
Agreed. Yeah, so we have a few questions in the chat. I would read out to you. First one being, is Julia compiler similar to that of Python?
I don't think the compiler is not similar. That's a good question. I think the Julia compiler uses LLVM, and I don't think that Python uses that. And Julia is also JIT compiled, and I don't think that I think Python is interpreted. So it's done differently. This is a sort of a pitfall for Julia in some cases, because again, with any sort of just-in-time compiled language, you have the initial overhead of the fact that it has to, if you had watched closely some of the stuff that was happening in my package manager, it has to pre-compile packages, it has to do a few things. So you sort of take that that hit sort of initially in a lot of cases, and then over the course of your sort of development for the day, it all that's where you really start to see the speed ups.
Okay, the next question reads as, how much time does it ideally take to learn Julia, as it the syntax is same to MATLAB, so how much time it usually takes to learn Julia as a beginner?
Yeah, this is a great question. I think it really depends on your comfort with programming. It also depends on sort of what specifically you want to do with Julia. I think, I learned this language called Solidity, which is used for Ethereum blockchain development. And I learned it in a day. But learned is such a unique word, because what does that really mean? That means, I know how to write a for loop and an if statement. Do I know how to do some of the more lower level stuff? And could I teach someone the language? Probably not. But I know just enough to sort of be dangerous with the language. So I would say probably a few hours, get familiar with the basic syntax and like the structure of what a Julia program looks like. But there's definitely some advanced concepts, and there's still a ton of stuff, even for me 3 years later learning Julia, that I still don't have a good understanding of. And that's just, again, because it's things that I haven't had to learn because none of the projects in the code that I've been involved with use those specific syntax.
So the last question we have for now is, I'm a first year in college and don't know a lot about computation and stuff, but want to learn this. From where do I start in this field?
That is an excellent question, and I again sort of feel that I'm in the same boat as Samik. You know, I'm more like classically trained as a computer scientist. You know, I know how to write code and things like that, but all of the specific applications in all these different domains are sort of the things that I have less familiarity with, and I'm guessing that's the same for a lot of folks. I think that the link for that MIT class is in the chat all the way at the top. And that is truthfully probably one of the best things that you can do to learn the language and learn all the computational stuff. And the reason for that is just that they've done a really good job of coming up with applications and sort of like exercises for the class, which are real world computational problems. Like part of it was, part of that course in previous semesters was climate modeling and things like that. Things that you won't necessarily learn about that unless you like take a graduate level class in climate science or something like that. But that's sort of part of the curriculum, and they can glaze over a lot of the high level details or the low level details rather about how climate science works, and just focus on the high level climate science plus Julia code and sort of what's the result of that. So that's a great resource for folks to use.
So Samik, I hope you got the part answered. Keep the link start. I think a lot of us are going to be following that for a while now.
Yeah, it's a great class, and there's a super, there's like an active sub community. I think the Discord for that class has like 3,000 students in it or something like that, and folks are always talking and working. So it's a great community to join, and there's a lot of other folks who are probably in the same position as you, where they're coming from some other school and they're just really interested in learning Julia in this specific class, which is awesome, and it's been great to see that happen.
That's great, Logan. The session was very insightful for many of the students that have attended it. So thank you from HackNITR 2.0 for giving us this wonderful session. We are very
happy to help.
Yeah, we are very glad that you made it in spite of the time difference.
Yeah, of course. I'm always happy to chat. And again, if folks have questions or things that I can help out with, feel free to reach out to me online or via email, and I'll do my best to help you all out.